Okay, Unit 9 is actually Chapter 10, and the first section is using the properties of tangents. So the first thing we need to do is define some vocabulary. So the first thing is a circle. Circle is a set of all points in a plane that are equidistant from a given point. And that point is called the center. The radius is a segment whose endpoints are the center and any point on the circle. A chord is a segment whose endpoints are on a circle. Okay, so you can see from the picture, radius goes from the center out to any point in the circle. Chord, segment, endpoints are on the circle. Diameter is a chord that contains the center of the circle. Okay, so it's important to note that the radius is a segment, the chord is a segment, and a diameter is also a segment because it's a chord. A secant is a line that intersects the circle in 2 points. And a tangent is a line in the plane of the circle that intersects the circle in exactly 1 point. And that is called the point of tangency. So it's important to note the secant is a line, tangent is a line. Okay, so we're going to match notation with the term that best describes it. And there's going to be 2 that I'm going to hit on the next page. And I'll touch on them briefly with this matching part. And these are a common external and a common internal tangent. So let's look at the first one, point D. Point D is on the circle with a line that intersects the circle at one point. So that is the point of tangency. Line FH. Line FH is going to be one of our common, since it intersects both circles. When we get to the other side, other page, we'll learn that if it intersects the segment connecting the two centers, it's an internal tangent. Segment CD from the center to the circle is a radius. Segment AB, since it is a segment intersecting the circle at 2 points, that is a chord. Point C is the center of the circle. Segment AD goes through the center, so that is a diameter. Line AB intersects at 2 points, that's a secant. Line DE, so it is a line that does not cross the segment that connects the two centers. It's only intersecting each of the circles at 1 point, so that's a common external tangent. Okay, finding the diameter and the radius of circles, and that's notation for naming a circle. So circle A, circle B is how you would use notation. So the diameter of circle A, just count across, 1, 2, 3 is 4. Oops, sorry. And the radius is 2. The diameter of B is 4, radius 2. So you can see that diameter equals 2 times the radius. Okay, coplanar circles. Two circles can intersect at 2 points, 1 point, or no points. Okay, coplanar circles that intersect in 1 point are called tangent circles, and coplanar circles that have a common center are called concentric. Okay, so there's some pictures to show you what each of those represents. 2 points of intersection, 1 point of intersection, which are tangent circles, and no points of intersection. A line, ray, or segment that is tangent to 2 coplanar circles is called common tangent. And there are two kinds, are the internal tangent, which intersects the segment that joins the centers of 2 circles. So if I had the centers here, and I drew a segment connecting them, you could see that the line intersects that. So this is a common internal. And if I draw this segment connecting these centers, common external does not intersect. The segment that joins the centers. So, how many common tangents the circles have, and draw them. So, I can draw a tangent here, and I can draw a tangent here. So this has two common external. These circles are concentric circles, so this has 0. And in number 20, I could draw a common tangent like so. It would be two externals. And I could draw two that way, and it would be two internal. Okay, in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. So if I want to find the value of x in these examples, you can see I drew a tangent segment that intersects the circle where the radius is. So x is the radius. It's perpendicular, so they're forming right triangles. So this is just a matter of using Pythagorean theorem. And taking the square root. Okay, and finding x in the next one, we're basically finding the hypotenuse. So 45 squared plus 108 squared equals x squared. So you're taking the square root of that. And 14 is very similar to 12, except x is the length of that tangent segment. Take the square root. Looking at the next ones here, now we have x is the radius. So we're basically trying to find the radius of these problems. And in order to do that, you need the length of the hypotenuse. So you have to use segment addition and add. So this would be x squared plus 32 squared equals x plus 16 squared. Okay, so you basically need to distribute that. So this means x plus 16 times x plus 16. Okay, so you would FOIL that. I have an x squared on both sides. 32 squared is 1024. So you get 32x equals 1024 minus 256, which is 768. Divide by 32, you would get x equals 24. Okay, I'm just going to do one more. I really don't have space for number 16, so let's do 17. Again, you must add these together. So you get x squared plus 63 squared 63 squared is 3969. FOIL this. That's 2401. The x squares will cancel. Subtract. And divide. Okay. All right, and then our last part here is tangent segments from a common external point, as you can see drawn there, are congruent. So, external point, two tangents, segments are congruent. Solve for x. Okay, congruent. Since there's no x term, I can just solve. Okay, and then in this last one, there is an x term. The only way you can solve when you have an x term is everything has to come to one side. Put the 5 there and the 1 there, plus and a minus. And then set each equal to 0. Okay, and this ends the first section of Chapter 10.